y'all hear me? Okay, so please bear with us. We'll be getting ready, hopefully momentarily. I hope you guys are prepared. Thank you. Yeah.
Do we have a backup? Because 15 is go.
Wait, no, I dragged it back.
That's his based on this one, right? Do you actually have the slide notes somewhere?
Want to start? Yeah, let's do this.
Yeah, we should be good at this stuff. Yo, slides are up there too now?
Sorry about that. But thank you guys all so much for coming, and welcome to the ACM Research Fall 2023 Symposium. We're super excited to have you all here, and we can't wait to show you all the projects that we have made throughout the semester. So without further ado, let's get started. For those of you who do not know what ACM Research is, we are basically a semester-long program that gives undergraduate students the opportunity to pursue research. UTD is a research-based school, but a lot of times opportunities are given mostly to grad students or PhD students, and that's where we come in. We provide 10-week programs with 10 different projects, all in completely random fields, given to people who might not have too much coding experience to help them learn and perform undergraduate research. Each team that we have here today is a completely different topic, and we're super excited to show them all.
All right, and this couldn't have happened without our executive team. Everyone applaud for Jocelyn, our president, and Ben, our vice president. All right, and I'm Ariane, I'm the co-director of research.
And I'm Cece, and I'm the other co-director of research.
Okay. And this could not have happened without our leads. And these guys have spent the past 10 weeks cultivating their timelines and working with their teams and their faculty advisors to get this situated. So up first we have Anish, who did coding semantics. We had Naveen, who did scaffold, and we had Nevela, who did forensic site. Then we have Philip with enhancing cancer detection, Rishit with exploring decentralized applications on Solana, and then Rohan with the blockchain based on federated learning. And then we have Rowan with leveraging explainable AI to mitigate bias, as well as Sambi with auditory unveil. And finally, last but not least, we have Vivi, or Vaishnavi, who is running the project Beyond Gaming, and Victoria, who's doing Conceal and Reveal.
So now for our judges, as y'all know, we cannot have these presentations without judges obviously checking y'all's project out. And so we thank the 3 judges here today that came out of their busy schedules to come and check out our projects. So without further ado, we have Sarah Walker from Toyota Connected. Would you like to say a few words?
Super excited to hear everybody's projects. I'm sure it's going to go great, so good luck.
I'm Professor Du at Computer Science Department, and I work on natural language processing. Good luck with the presentation.
Hey guys, my name is Abhishek. Fun fact, I was actually a research mentee and a mentor, so nice to be back with everyone, and good luck to everyone.
So now we're going to get started with presentations. So the teams, please, as a reminder, you will all have 7 minutes to present, followed by a 3-minute question period with the judges asking questions, and then between each presentation, you'll have 2 minutes of transition. When the team before you is going, we will call you guys up to go hang out in that corner so that y'all can prepare and make sure that you guys are set for your time when it's up. So without further ado, let's introduce Beyond Gaming.
Looking good.
Bro, what are you doing?
I'm waiting on the stream to start.
Oh, what stream are you talking about?
The Exploring Interactive AI Virtual Streamers in 2D and VR Environment stream. It's about to start, so let's go.
All right. So, hello everybody. I'm Jose Garcia, and I'm the Asteroids game dev.
Hello everyone, my name is Suresh and I was a Python dev.
I'm Corbin Schultz, I was a Donkey Kong game dev.
My name is Abbas and I was the Dino game dev.
Sup chat, my name is Terrell and I'm the Flappy Bird game dev. So first, we're going to talk about the overview of our project. So this is Vivi, our AI virtual streamer, and the star of the project. She is the product of many different ideas and inspirations, the biggest ones being Neurosama, an AI VTuber, notable Twitch personalities, as well as VR chat.
So like Terrell just mentioned earlier, Neurosama is an AI VTuber, which is basically just a regular streamer but with a virtual avatar. So what our group did is we essentially created our own Neurosama, except like we named her Vivi, who can read Twitch chat, play games, generate comments based on those games, and create facial expressions. But what we did is we essentially took this a step further by deploying Vivi in a virtual reality environment.
So currently, the traditional streaming experience leaves much to be desired for the user in terms of immersion and engagement. Thus, we are researching ways to fulfill that user immersion, such as haptic feedback, including interactable avatar, as well as creating personalized one-to-one user experiences.
Now let's explore how Vivi came to life. So as you can see, we have two different types of users. We got PC users and we got VR users. So the way PC users are able to communicate with Vivi is through Twitch chat, which will be fed into a large language model that will retrieve a response that will allow Vivi to respond back to the PC user. And VR users are able to communicate through speech and haptic interactions that will similarly be fed into a large language model and be fed to Vivi that will allow Vivi to communicate back. And games, they are accessed through a simple reference like, Vivi, play Asteroids, and she will do so.
Alright, so we powered our streamer using the GPT 3.5 LLM, and how that works is we'd essentially pass it context, which will contain information regarding the game being played, and wherever the Twitch chat saying at any given point. From the LLM, we then receive a response that has two main parts, one of which is emotion that we would display, which we'll talk more about that later. And the other part is the text, which we then send to GCP's API, which is how we'd actually convert the text to the speech that you hear on the stream.
So for PC users, Vivi gets her input from reading Twitch chat and generating responses based on that. However, for VR users, Vivi gets her input from listening to the user speech. The reason why we did it this way is so users can have a more personalized and like face-to-face experience, kind of like what I'm having with all of you right now.
So the avatar was created through Vroid Studio. Now, unfortunately, AI doesn't come with a personality, so we decided to give this AI some personality via prompt engineering. And additionally, we gave some background lore as well as for viewers to enjoy when they watch the stream. Now, additionally, as Corbin was hinting at earlier, our AI, whenever the LLM generates text, it has a sentiment attached to that specific response. And so the emotions you can see in the GIF above are going to be played and mapped to that specific sentiment. So, like for happiness, whenever the statement is happy, it will have the happy emotions.
Furthermore, we use Blender and mixed mode animations. So for example, when Vivi starts to stream, she'll wave to the user. And additionally, we use Unity hand tracking for haptic interactions. Essentially, this means in VR, the avatar is able to engage in interactive gestures. For example, if I was a user and a boss is a streamer, I could raise up my hand for a handshake, and boom, the exchange is completed. Moreover, to do this, we're using haptic gloves so that users can actually feel the interaction, like doing handshakes and high fives. And this is all just to create a more immersive experience.
So we created 4 games within the Unity game engine, and those 4 games are Asteroids, Donkey Kong, Flappy Bird, and the Chrome Dino game. And we have a game menu up there to display the game switching as well. And so these games were trained with an AI using the ML Agents Unity package. And in ML Agents, it utilizes reinforcement learning, which is essentially a reward punishment system in which you're rewarded for doing well within the game, and your agent is punished whenever failing to meet a certain criteria. So you can see from the graphs to the right there, this is our agent progress over time. And we can see an increasing reward over time, meaning it's training well.
This is our stream slide. As you can see in the first picture, you will notice that we use Streamlabs to create an overlay and record our stream. We also use Twitch's API to be able to live stream on their platform. On the bottom picture, you will notice a VR scene. It's designed to look like a small room with a TV. The TV will display our stream, and Vivi will also be displayed within the stream.
'And now we'll be presenting 2 demos.
And now we'll be presenting 2 demos.
2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 demos. 2 UWU. Of course, I'd be happy to play Flappy Bird. Just give me a moment to set it up. UWU. My favorite person is Mr. Peachy. He always brings a smile to my face with his kind and caring nature.
Alright, now we'll show a VR demo as well.
Hello, how are you doing today?
Hello, I'm doing okay. Thank you for asking. How about you?
I'm doing well. Who are you?
I'm Phoebe, a girl from the year 2030. Nice to meet you. How can I assist you today?
What are your favorite hobbies?
My favorite hobbies include collecting comic books from Corbin's comic book store, playing League of Legends, and fishing with my friend Jose. What about you? Do you have any hobbies that you enjoy?
I like reading books.
Alright, now we're talking about the results from our project. And the results from our 2D environment essentially show how our streamer could interact in a standard stream settings, but through this experience we determined putting her in a VR environment will create a more immersive experience for viewers. And this would also introduce the opportunity for the streamer to respond to spatial interactions around them.
And a special thank you to ACM Research, Dr. Kim, the MI Lab, Ayush and Ashish from the MI Lab, and our research lead, Vivi. And here is our poster.
Hello guys, is this on? Hey guys, great presentation, loved it, very interactive. Love the concept too. I just had a question. Obviously, content and what types of things come in chats, in Twitch chats, it's very controversial sometimes. So just asking, how do you guys plan that BB kind of reacts against hateful comments and hateful content, that sort of thing, just content moderation, just to make sure nothing bad is being said or anything like that. So yeah.
Okay, cool. We don't got a microphone up here, but essentially to handle that, I know you can handle that on multiple ends. So on Twitch, you can have bots to auto-filter out some type of messages, so that'll handle it on that side of it. But aside from that, considering the time frame that we had to work with, we didn't necessarily have time to fine-tune an actual model, so we couldn't filter out, that type of content in that sense. Yeah. So since we're essentially using a custom prompt, which is how the personality is displayed, we could include that inside the prompt, but I'm not sure if you've experienced how GPT receives prompts. So it sometimes isn't receptive of all the details. So there's no guarantee that it would only work completely if we did implement that, but we do the best we could considering that though.
Great presentation, really liked the demo. Just a quick question about ChatGPT and I think you guys mentioned that it would return a text response as well as a sentiment, is that correct?
Yes. Yeah.
So I was just curious what the sentiments were that it could respond, and also if you ever found that there was a mismatch between the sentiment it returned and the actual text it provided.
Yeah, so some of the sentiments that we had were happiness, joy, sadness, anger, I believe sorrow. And when I was testing it using my prompt engineering and just running the code several times, there wasn't really much of a mismatch. And the reason for this is because GPT 3.5 was trained on a large corpus of data sets. So it understands, it has a good understanding of the human language, and it knows what emotion should be displayed based on how it responds.
You mentioned that you are creating the personas with the prompt, right? The personas with the prompt for the characters in the game. And how?
Oh, so what we did is we essentially had a text file that contained the personality for Vivi, her background story, how she should respond to certain questions. And in the code, we say that the role is system, which basically just means that that's the instruction we're giving it. And then I just pass in the path to the text file. So when the code is run, the API gets that information. And based on that, its responses are tweaked.
So does it mean that the persona is fixed or it can be specified by the users?
It is fixed, so the user does not have the ability to change that, but that could be a future goal where we can give the user the ability to change the personality.
Finally, can you briefly explain the evaluation process? Is it like based on user studies or what?
The user study was actually a future goal that we were going to implement, but given our time constraint, we didn't necessarily have the time to come up with a confirmed decision for our research.
All right, give it up for Beyond Gaming. All right, next up we have Rishit's team, which is, I believe, exploring decentralized apps on the Solana blockchain.
Alright, Solana versus Arweave, storing and manipulating data in blogging sites. So here's our team. My name is Rishit.
My name is Ridwan. So the focus for our research project was to compare which blockchain offered the best solution through the lens of a blogging application. Ever since the internet has existed, people have been writing and sharing their ideas online through their own blogs. While this has shifted to other sites such as Medium, Blogger, Tumblr, and many others, they all lack one key thing, and that's privacy. Due to a fear of sharing their controversial opinions, censorship, or just being under constant surveillance, people just aren't able to do that. And that's where blockchain comes in. So what is blockchain? Put simply, it's a digital ledger of nodes. All of these are connected on the same network, creating a peer-to-peer, decentralized, and anonymous network. It stores transaction data, as well as self-executable code known as smart contracts. Upon being deployed, it'll be there forever and is completely immutable. These nodes then come together to form chains, and it's done this through cryptographic functions. So what does this all mean for our blogging application? Well, it means that when it's deployed, it can be done so anonymously, securely, and efficiently.
So our approach when it came to this project was to compare two different decentralized networks, those being Arweave and Solana. Those are quite different in their approaches to creating their own decentralized network, which is why it's a great candidate to compare for a project. Something we want to mention before we go ahead is saying that this is a research journaling approach. So what we're doing is we're taking two different blockchain networks, we're comparing them, drawing results, and we'll be using that hopefully for future research or for other researchers who want to use this for own data. So what's Solana? So Solana is a high-performance blockchain network that focuses heavily on high-speed transactions, but very low transaction costs. So this is great when it comes to decentralized applications. For example, in comparison to something like Ethereum, Ethereum has much lower transaction speeds. So in this way, Solana really improves upon that.
So what is Arweave? Arweave is another program designed on a blockchain. It was designed for permanent and tamper-proof storage with a one-time transaction fee model for predictable costs. It also utilizes the decentralized nodes, ensuring data redundancy and availability, which also ensures resiliency in times of attack or failure. Arweave is also popular for its data archival, but it also has a growing developer community. So this allows for easy integration for future applications with existing data storage infrastructure. So in regards to data storage on Solana, it's stored in blocks. Also, programs use accounts. Metadata also has certain access permissions. Accounts also utilize a rent system using tokens known as lamp ports. And finally, there's two types of accounts, executable accounts and non-executable accounts. Executable being immutable, while the second being mutable even after being deployed on the network.
So data storage in Arweave is done a little differently. They use what they call the permaweb. It's essentially a way to store very large files on this decentralized network. They work really closely with the Internet Archive, and it basically makes it so all the data on this blockchain is very tamper-proof and censorship resistant. One other thing we'd like to note is that this blockchain can be actually utilized with other blockchain networks, such as Solana, in their decentralized applications to store a lot of data. So here's our findings, and here's eventually we'll go to our conclusion. On the Solana side of things, we saw that storing large amounts of log data on Solana is very inefficient, and the running costs are really high. So the best idea is to have a backend database, but the issue with that is it kind of creates this centralized storage, which we'll elaborate on further. But a lot of the transaction on Solana for logging essentially boils down to user interactions and account creations. So this is like when you create an account, delete one, create a post, etc. Looking at one of the biggest blogging websites, Blogger now, on average they get around 5,750 blogs being created per minute. And since every blog is around one transaction, that's the amount of transactions per minute. So here's our Solana transaction code. It's a little small, but essentially what happens here is that a transaction is being created regarding some data. It's being signed at the end, and it's being sent to the blockchain.
So on the Solana side, as is with any cryptocurrency, it has a fluctuating price. At the time of gathering our data with the 5,700 transactions, we found an average price of 0.05 SOL, or a total of 1.37 cents. So it goes to show that it's a low-cost and viable solution for any future blogging applications. So on the Arweave side, we found that the Solana was 24 times more expensive than storage on Arweave when taking into account a gigabyte of transaction data. Looking at one of Arweave's applications built on its permaweb, ArDrive, you can see that it's a low-cost, long-term solution, much better than some of the consumer standards like Google and Dropbox. So this is some of our blog posts and transaction code. So we can see that it first creates the transaction, signs it, and then submits the transaction to the network.
So the question comes in is, which one's better? Well, the answer is a little complicated. So essentially, okay, so there's a lot of drawbacks when it comes to either one. But the biggest drawback with Solana is that you can't really store a lot of blog data, which makes it so that you kind of have to use backend servers, creating this whole decentralized application, which defeats the whole purpose of decentralization in the first place. And Arweave, the issue with that is you can only store static data, which means that once it's on there, it can never be deleted, or edited at all, which is kind of a problem when it comes to blogging data, because as soon as something, so for things like likes, comments, and editing blog posts, it's pretty much impossible here. So our conclusion is pretty much to combine the two. We can use the speed of transactions of Solana, we can use the low cost of Solana with the storage capabilities of Arweave, and we can essentially combine those two to create a fully decentralized, totally anonymous blogging website. One thing we want to mention again is that this was a research journaling route again, so this is us taking two different networks, comparing them, creating some conclusions so that it can be used for further research. So here's the references, and do you have any questions?
Great presentation, good job. So just a quick question. So at the end you mentioned possibly doing a solution where it was Solana and Arweave combined. Is that something that you guys have tested out, or is this just something in theory that you feel would work?
We wrote a lot of code for the Solana side of things, and we wrote some transaction code for Arweave. We didn't really have time to combine the two, but effectively, if you look at the code, you can combine the two for the transactions from Solana, and you can kind of combine it with the data storage, large data storage from Arweave. and that should come together pretty easily.
Cool, thank you.
Presentation, great explanation of the two blockchains. So a question is that, so you guys talked about how you guys were analyzing blog posts and it was what, 5,750?
Yeah.
So is it that you guys took in 5,700 blog posts, stored it somewhere, and then went through the process, or was it like a streaming process where you guys were passing them one by one? And did you pick a number for why just 5,000? Was it just like resource or time issues or what?
So using, when we saw that 5700, we had that formula there, so that was enough data for 1 gigabyte, so we kind of set that as the standard too.
And so that's kind of the, I'll just elaborate. So that's kind of the average transactions. We use Blogger because Blogger's been around for a very long time. And we just saw that transactions per minute, so we kind of just use that to base our assumptions on what a popular blog site would be.
So just to, so you guys took that number as a rate, and then you downloaded those blog posts, and then you passed them through.
Yeah, we essentially passed it through.
Thank you.
Okay, next up is Evita's team with Forensic Site. One moment, please.
Ouch, my arm, it hurts.
Fear not, victim, for Dr. Forensics is here. Wow, how am I going to classify that?
Well, doctor, you can use the forensic site model.
You're right. Introducing Forensic Site. We plan to intersect both criminology and technology using computer vision. Our goal with this project was to facilitate one of the most time-consuming aspects of criminology, which is blood classification and documentation. My name is Shriram.
My name is Abyss.
My name is Arushi.
My name is Zara. And my name is Amelia. Our objective is to create an AI model using machine learning techniques to recognize and differentiate distinct blood stain patterns accurately. The two primary ones are passive stains, which are typically small and result from the force of gravity acting upon the blood, causing it to fall or drip. And transfer stains, which is an object or body that contains blood that comes in contact with the surface, leaving behind an imprint or a pattern. These can be, for example, bloody handprints.
Alright, so before we move on to the data set, I would like to give everybody a fair trigger warning, as the next couple of slides does have real blood samples on it. Alright, so the data set. We started off with a base set of 300 images, and these 300 images were classified into two main categories. First being the type of bloodstain, which was transparent passive, and the second was the type of surface this bloodstain was found on. And these surfaces ranged anywhere from the table, carpet, bathroom tiles, human skin, and there were certain pictures that had multiple surfaces in the same image. For instance, a blood drop being on the floor and somebody walking on top of it, creating footprints, all leading onto the carpet or the bathroom tiles respectively. Then these 300 pictures were pre-processed, creating bounding boxes around them. These bounding boxes basically identify the type of stain on that particular image. And then these pre-processed images were lastly gone under standard industry augmentations, which included rotations of 3 types, which were 90 degree, 180 degree, 270 degree, and vertical flips and horizontal flips.
So for this tech stack, we decided to use YOLO v7 as our object detection model. We chose this model because of the ability to do real-time object detection, which it does in 2 parts. First, by identifying regions of interest in the image as a whole, and second, by classifying it with our aforementioned passive or transfer. In tandem with YOLO v7, we used RoboFlow for our dataset management, which in our scenario we used to manually label our dataset, which we later then plugged into YOLO v7.
Our training involved two major steps. Number one, the training runs themselves, and number two, the evaluation of each of these training runs. We trained our model over 300 epochs, which is essentially just feeding our data set through YOLO v7's algorithm to detect patterns and then eventually our final model. After which we evaluated our models on three different metrics. Number one, the precision, which is the percent of the time the model correctly predicts a class. Number two, the recall, which is the percent of the time the model can accurately find a class, given the number of that class that exists in our data set. And number three, the MAP score, the mean average precision score, which is the overall accuracy of the model as a whole at two different IOU thresholds, intersection over union, which essentially just tells me the overlap between the predicted bounding box and the actual bounding box. So our results as a whole, we ended up with a precision of 81%, a recall of 65%, and at an IOU threshold of 50%, we had an MAP score of 71%, and at an IOU threshold of 95%, we had an MAP score of 45%. This tells me two major things. Number one, that while our model is precise when it can find a class, it has difficulty finding classes in the first place, based on a high precision and a lower recall. And number two, it tells me that at an IOU threshold of 50%, which tells me that there's a 50% overlap between the predicted bounding box and the actual bounding box, Forensic Psych can actually accurately predict what class it is 71% of the time based on that MAP score at that IOU threshold. And the final metric that we used to evaluate our model was the confusion matrix. Now, while the confusion matrix may look confusing at first, it's actually fairly simple. At the bottom is the true class, and on the left side is the predicted class that was predicted by our model. So typically, a good confusion matrix would have darker boxes going from the top left diagonal to the bottom right diagonal, indicating that the class predicted by our model is actually the true class that it actually is. In the case of Forensic Psych, 83% of the time, when it was a passive stain, it predicted a passive stain, which is fairly good. But 48% of the time, when it was a transfer stain, it predicted a transfer stain. This value is a little low, but something that could easily be improved upon by having more transfer images in our data set as a whole.
Okay, moving on to challenges. Unfortunately, throughout our entire project, we faced various challenges, most notably within labeling, augmenting, and training. So when it came to labeling our dataset, since everything was done manually, there was a lot of inconsistencies. And the same thing could be said when it came to our label files, because everything was in polygon format instead of our desired bounding box format. As for augmentations, it was very difficult to determine the most optimal form of augmentation without sacrificing our image quality in our dataset, in addition to developing code for our labels, label files, our augmentations, and resizing all of our images to uniform square sizes. As for training, it was very difficult to work with YOLO v7 due to the configuration files, in addition to realizing that our dataset was quite small, which would not lead to our desired accuracy rate. Last but not least, since nobody had an RTX 4000 at hand, we had to rent GPU servers, which placed some financial limitations on us. Now, despite all the complications we faced, we've managed to augment over 900 images with a 71% accuracy rate with our model. And from our research, we've been able to deduce promising MAP scores in addition to significantly reducing the amount of time it takes to analyze blood in crime scenes. And last but not least, there's always room for some growth, and our team is absolutely dedicated to improving our model to be greater accuracy in the future.
Before we conclude our presentation tonight, we would like to present our heartfelt gratitude to our leader, Nevada, our faculty advisor, Dr. Kim, and Philip for their exceptional mentorship and leadership. And without their support, we wouldn't have made it this far tonight.
Here's a poster that describes our research project. Thank you so much.
Guys, representation, love the dramatic intro. So you guys mentioned that you guys got 900 images manually intake. Great job on that. It takes a lot of work. Can I just ask, what was the breakdown of how many images were passive and how many images were transferred?
I want to say for a rough estimate that we had around like 40% of our images are transferred and the other are passive. Of course, that is like split up between the training, the validation, and the test data set. So overall, those are the numbers typically. Rough estimates.
And then while you guys were annotating the RoboFlow with the RoboFlow, whether they were passive and transfer, did you guys have how was that process of finding, because if I was to tag, if it was a pass or a transfer, there might be some issues or mistake that I would make. So how did you guys ensure that when you guys were labeling that, it was the correct labels on your side?
Right. So in order to do that, the data set that came with the images also contained an Excel sheet with manually edited and description and classifications of what each image contained, and yeah, that's how we were sure on exactly what the image had to have. The only thing that we had to do was manually find where the boxes would be on the image.
Nice presentation. I have a question regarding the evaluation, and you mentioned that you use precision and recall. Which one do you think is more important here?
I think for the case of our model specifically, looking at the values, a precision of 81% is a fair value, at least for something that is done within 10 weeks and within a small time. So I would say that a recall is a little bit more important for us to focus on, because having a lower recall indicates that the model is having difficulty finding images in the first place. I mean, if you look at a confusion matrix as well, the bottom row of we can go back to the confusion matrix real quick. Confusion matrix slide. The bottom row of the confusion matrix is the indication of background false negative, which essentially indicates that it's not finding anything in the first place in those images. And that's something that easily could be fixed by having more of that image within the data set. So that's why I think the recall value is something we should definitely focus on as we proceed with our research forward. I hope that was a good answer.
Yeah, I mean, from my perspective or impression, it's like for your task, recall is more important than precision, right? You want the tag as more, what's the term here?
Bloodstains.
Bloodstains as possible, yeah, right?
I just had a question about technically how it was working. So you found the model was finding the bounding box of the bloodstain. When it was doing the classification, was it just looking at that area that it found, or was it looking at the whole image?
So the way that the model works is based off, again, the YOLO v7. So YOLO v7 takes the image as a whole and it identifies bounding boxes within it. So we're not so when it takes in its training information, it will look at the bounding box specifically, but when we're testing, it takes the image as a whole, and then in that, based off the images we've given in training, it can identify locations in the test to find where the bounding boxes are. I hope that answers the question.
That answers. Thank you.
All right, give it up for forensic studies. So the next team that we have presenting is leveraging explainable AI. So give it up for them.
Have you ever been betrayed? Do you struggle to trust other people? Do you ever wish you could look inside another person's mind and understand what they were thinking? Unfortunately, you can't. But with explainable AI, we can begin to understand the thought processes behind AI models. My name is Rangadur.
I'm Aaron Bertwell.
I'm Keelan.
I'm Laya Srinivas.
And I'm Sonia Oak.
And we are leveraging explainable AI.
So what is explainable AI? Basically, imagine a situation in which you have to make a huge impact regarding finances or a medical situation. I know it's a big decision. How can you use AI when you have no idea why it's going to a decision the way it did? So, generative AI helps uncover the black box between AI. It tells you why it came to its decision, and it doesn't say, listen to me, I'm right, you're wrong. Instead, it tells you all the reasons why it did what it did. Our goals for this project was to evaluate how well XAI can analyze and report biases, how effective it was in determining a bias in a machine learning model, to show how predictions were made, and show the comprehensibility, to show how the patterns were visible to the human eye.
Looking at the technology that we implemented in our project are Lime and Shap. Lime and Shap are two very popular XAI tools, largely due to the fact that they are both model agnostic. This means that they can be applied to a wide variety of inputs and a wide variety of predictions, ultimately making them applicable for a very diverse pool of models. Our model is an image classification model, meaning that the input were images and the predictions were classifications of those images. The way that Lime works is through perturbations or alterations of small features of the inputs. In our case, those would be small aspects of our images. And Lime alters those small features and measures how that affects the prediction made by the model. Shap, on the other hand, operates through the calculations of Shapley values. These are values that effectively measure how heavily for or against a given prediction each feature of an input acts.
We used an open source data set by Moses Olafenwa called IdenProf, including 11,000 images of visually identifiable professionals within 10 classes, such as doctors, chefs, engineers, etc. We had three kinds of bias introduced into our data sets. The first kind were watermarks, where we manually applied watermarks to the chef and doctor classes. The second of which were uneven data sets, where all of the classes had 600 images and the chef and waiter classes had 900, introducing an imbalance between the classes. And the third kind of bias we introduced was homogeneous data sets, where each of the classes were manually altered so that the images within them were more visually similar to one another and had similar characteristics, reducing the overall diversity of the data set. We used a convolutional neural network for our model consisting of 2 layers using ReLU activation. Before putting our images through the model, we conducted data augmentation on them. So we arbitrarily applied transformations such as random horizontal flips, resizing, messing with the colors. This introduces more diversity into the data set and makes the model better at generalizing, which should increase accuracy.
So first off, applying SHAP. So whenever we applied SHAP to our data set, we saw that the watermark data set actually resulted in the most results for seeing any patterns. As seen on the left-hand side for 5 different images, we see the SHAP patterns for the chef class as well as the doctor class. And since these 2 classes were watermarked, we see that on the chef class there is a X formed by SHAP values as well as a horizontal bar formed for the doctors. And so those are the most patterns we found. However, for the other biases that we had, such as homogeneous and uneven, we did not see as many visible patterns showing like the biases for the sets. So overall, SHAP does respond to specific visual biases such like watermarks, however, it does not respond as much to other biases such as uneven homogeneous sets.
Throughout the weeks, we focused more on SHAP rather than Lime because of the newest applications it had. As we got closer working on Lime, we realized that as we were able to do the graphs, there were some files we were unable to transfer over from different models into our model. Due to the time constraint, we were unable to have more time to focus on bringing the files over. Therefore, we focused more on the applications that SHAP offered instead.
In our project, while delving into model analysis with Lime and SHAP, we faced 3 main challenges. Firstly, navigating the complexities of Lime and SHAP required expertise, and our team initially grappled with the learning curve on these tools due to inexperience. Second was the issue of low model accuracy, which added another layer of complexity as we required accurate predictions to derive meaningful explanations. And lastly, our efficiency was also impacted by the limited availability of tools. All of these challenges in our project demanded continuous learning, refining of our models, and exploring additional resources. These challenges also fit into the broader context of analyzing machine learning models using Lime and SHAP. These black box models and also using an image dataset, which required high-dimensional data interpretation, led us to understand the need for a more nuanced approach for the effective use of these tools. Thank Thank you everyone for your time and attention. We are now open for questions.
Great presentation. Just a general question about like how you guys broke up the work. So were you training the model initially, and then on top of it you were using Line, or did you use like a pre-trained model for the initial analysis?
Right, so we focused a lot in the first few weeks on building the model and trying to get the accuracy as high as we could, experimenting with a few things, and then we turned our attention to our XAI methods.
Thank you.
Hey guys, good presentation. Quick question. So that watermark dataset, so you guys put the watermark on it, or did it come with the watermark? Just wondering.
We used a bulk watermark tool and just applied watermarks manually to the data sets. For the, I think it's a chef class, we just used a watermark across the image diagonally. So in the XAI, in the SHAP graphs, you can see an X going across the graph because of the horizontal flips. And for the doctor, we put in timestamps, so you can see those flipped again.
And the timestamps, that was just like random timestamps, or
yeah, it would just number the mock-up a timestamp.
Did you guys think about maybe using some other, I guess, image features? So, for example, some metadata along with the images to maybe see if Chat would be able to predict not only with the image but also numerical. Just wondering if that was that. Did you guys go through that?
I think SHAP specifically uses the image data. Is correct, right? So metadata wouldn't be considered in creating the Shapley values.
Nice presentation. So, firstly, the title is a big area and it covers a lot of subtopics, I think. Do you think your approach or methodology proposed can be generalized to other domains, or how well it will generalize to other problems?
Well, I believe that our methodology was applying making a model as well as applying SHAP. Because SHAP and Lime are model agnostic, it can work across many different models. So whatever data set and whichever model you want to use it on, it will work on any of them. It will as well it will show values for both images as well as raw data as well as numbers. So it will work across many different fields and many different data sets.
Thank you.
All right, thank you guys. Next up is Victoria's team, Conceal and Reveal.
Hey guys, and welcome to a deep dive into steganography and steganalysis. Steganography, the practice of concealing information in various content such as images, text, audio, or video to avoid detection. Guys, I just received a notification. It looks like communication channels have turned back on. What does it say? It says adoption opportunities for kittens?
What? Why would they show us kittens?
What could they be concealing in there that we could reveal?
Welcome to Conceal and Reveal, a top secret CIA operation led by Team A514 Charlie Echo. I'm Isma.
I'm Ramina.
I'm Aria.
I'm Lurch.
And I'm Daniel.
And our research lead is Victoria, and our faculty advisor is Dr. Muran. Our goal is to intercept communications between hacker organizations to protect national security. So as cute as this image is, it may contain steganography, which is the practice of concealing information or a message inside of an image. From there, we can use steganalysis to reveal what that message is.
I wonder if I could use the Python model stegano to uncover the message. Oh, got it.
Now you might be asking, what is stegano? Well, stegano is a type of Python library that we can use to apply steganalysis and steganography through Python code.
Looks like the final message was the drop will occur at 9:45 on the 12th of December. Be ready and erase the message when received.
So listed here is one of the methods that we researched during the course in our semester, at least a significant bit, as well as 3 of the algorithms that we implemented during our research: GNORD, JMI pod, and UERD. So during the beginning of our research, we looked into various different ways to hide and reveal messages, and we even branched out and looked a little bit into encryption and cryptography. And one of the simplest steganographic methods that we came across was the least significant bit, which works by altering the last digit of a pixel. Our algorithms, however, utilize a bit of a more complex steganographic method called DCT, which is short for discrete cosine transform, which essentially works by, instead of altering the pixel of an image, it will alter the frequency of an image in order to hide that message. And so over here, the GNORD uses the DCT coefficients by hiding data in the textured and noisy areas. The JMI pod takes a bit of a more narrow approach and specifically focuses on the zero frequency components of the DCT. And the UERD takes a more general approach and focuses more on just the visual quality of the photo.
Guys, I just received 75 more attachments from that email. 75? How are we supposed to go through all of them in time?
What if we use machine learning? I mean, we could go through as many as 300,000 images in a time.
You're right, we can use machine learning to analyze data patterns and make predictions using various algorithms. From there, we can train an ML model to do the steganalysis for us.
The dataset that we're going to be using is the Alaska 2 dataset. Now this contains over 5,000 testing images and over 200,000 training images. Of these training images, 1/4 of those are cover and the rest are all have messages concealed with one of these 3 algorithms.
So, the models that we'll be using today to test out steganalysis will be support vector machines, SVMs, convolutional neural networks, CNNs, and the specific architectures we'll be implementing include sklearn support vector classifier, ResNet50, and EfficientNet v2. So, starting with support vector machines, what are they? Well, an SVM is a type of shallow learning model that takes data and plots them within an n-dimensional space based on n features, and decides a best fit hyperplane to then classify all that data.
And then we chose convolutional neural networks because they're state-of-the-art for image classification tasks. So basically we thought they could pick up on the weak steganographic signals left by the algorithms.
Next up, we have the ResNet50 architecture. This is essentially a deep learning CNN model that helps with the vanishing gradient issue. This issue occurs because during backpropagation, gradients are calculated and then used to update the model's parameters. However, when you have a lot of layers, the gradient gets really, really small, and this causes the machine's training to slow down. However, this combats it by using skip lines, which skips over certain layers.
And then we use the EfficientNet architecture, which basically scales by, I don't know if you can see in the picture, like width, depth, and resolution. And the model authors basically found good coefficients to increase accuracy and decrease computational cost.
So beginning our results, we can look at the SVM support vector classifier. We decided to go with 2,000 images, which is a lot smaller than Alaska 2, due to the fact that it is a shallow learning model, and therefore operates better with a smaller dataset. And as you can see with the following confusion matrix and the classification accuracy, we achieved an accuracy of 53%.
Next up, we have the results of binary classification with ResNet50. As you can see, the model accuracy came out to be around 74%, and the validation accuracy was greater than the training accuracy.
And then for the efficient net, we found model accuracy was slightly worse at 68%. And then you can see in the accuracy graph, training accuracy sort of supersedes the validation, so we sort of thought overfitting was going on there. And so just for general analysis comparison, we found the ResNet was a bit better at learning, especially looking at the loss graph, the lines sort of move in tandem. Whereas for the efficient net, the loss graph on the bottom right, the training loss is sort of like plateaued. And then, yeah, we briefly tried multi-class classification, again with the efficient net. We got our accuracy to around 35% at 12 epochs. You can see the accuracy was steadily increasing, but we weren't able to train as much as we wanted. And yeah, it just kind of shows how hard it is to detect the differences between different algorithms.
Overall, this was quite a journey. We definitely had a few challenges. There was a big learning curve in learning machine learning terminology, using the new tools to collaborate with each other, and increasing our model accuracy. Takeaways, I'm sure I can say for all of us, we had a lot of growth, and in terms of future plans, we hope to improve multi-class classification results, extract handcrafted features such as DCTR, and experiment with different architectures.
Thank you, and remember, the information you learned today cannot leave this room.
Nice charts. I wonder if you have any baselines or more insights from the results.
Not sure.
What are you comparing with?
I guess we were just sort of comparing the convolutional neural network models. So the ResNet we found was a bit better in terms of accuracy, and it was also the training was slightly faster.
So how do you define what is a satisfiable performance for practical use, for example?
Yeah, so I guess looking into precision and recall would be good here. I think for the Alaska 2 dataset, they wanted to minimize false positives, or false negatives. I can't remember it exactly, but it would be good to include that, maybe those metrics during training next time, and also doing more epochs. We only got around 6 to 8.
So I noticed you also talked about it that the training loss plateaued out. Did you guys experiment with hyperparameters in the ResNet 50 and EfficientNet models to see if maybe a different configuration would help with better training losses?
Yeah, I think we wanted to do a simple ridge search, sort of how we did for the SVM. We kind of lowered the learning rate some, and it would have been nice to. We also had a scheduler on plateau, so learning rate would decrease on a plateau for validation accuracy. But yeah.
All right, thank you guys. All right, so after a really long time, we are on break, and we will be serving dinner. Now, we will be doing it table by table. So, how do you want to do this, Cece?
Yeah, so as Aryan said, we will be doing this table by table so that we don't ensure any chaos. So please sit down, and then when me and Aryan come around to your table, you can get up and go get food. In terms of food, we have very, very, very good catering today. We have chicken biryani, veg biryani, and samosas. Shiras, sorry.
If provided via Shalimar, it's a place of giving. Y'all should check it out.
I will go.
For those of y'all that missed a four, we do have more in the back.
Hey everyone! If y'all are missing a fork, there's some more in the back now. Please, you can go grab some over there.
Yes, yeah.
please welcome Coding Semantics.
All right, our project was Coding Semantics, Sentiment Analysis for Movie Reviews. I'm Jack.
I'm Edwin. I'm a third one. I'm Aditya. I'm Pranava.
And, okay, our research lead was Anish, and our faculty advisor was Dr. DeGroot. Here's a quick overview of our presentation. We'll start with the introduction. So our research involved making different natural language processing models and comparing their effectiveness. So our research question is, which model is most effective for sentiment analysis of movie reviews in determining whether a movie review is either positive or negative? And looking at our data set, it contained 50,000 different IMDb movie reviews.
So for the dataset, we first needed to pre-process it to cater it to semantic analysis and classification. So we did this in 3 ways. First, we removed all symbols, and then we removed all stop words, and then finally, we lemmatized the dataset so that all words with similar meanings were grouped together. And then we needed to vectorize our dataset, which we did using sklearn's vectorizer, and then it was ready. Our dataset was ready for training on the models. So these are the 3 models that we use. First up, XGBoost is an extreme gradient boosting library that uses depth-wise tree growth and regularization learning techniques to limit overfitting. So to actually use this, we needed to process our data set a little bit more to put it into the classification task standard for XGBoost. We did this by changing the labels to zeros and ones, and then also converting our data sets into D matrices. We chose this model for its pros being computationally efficient, high customizability, and again, the regularization techniques to limit overfitting. And for its cons, it's obviously going to lack the contextual and semantic understanding that a large language model would have. And another con would be, despite its ease of use, the amount of customizability it offers actually does contribute a little bit to the complexity in setting it up.
So the LightGBM model is also a gradient boosting model that we use, which is histogram based, and it uses one-side sampling, which essentially takes focuses on data that has larger gradients. And so we also utilize the TF-IDF vectorizer to change our text into its numerical features, which help capture the level of importance in certain parts of the text. In terms of pros, the speed and efficiency of LightGBM is very good, which means it's good for large data sets, and it's also accurate, which means that it's reliable. It can handle categorical features well, so extensive pre-processing is not needed, which is good for diverse data sets. And it's also scalable, which is good for when data sets are growing. In terms of some cons, adjusting the hyperparameters needs to be done carefully, and potential overfitting can also happen from overtraining, so especially for smaller data sets.
The third model that we use, BERT, is not the gradient boosting framework. It's a bidirectional encoder transformer-based model, and it uses a deep neural network pre-trained on a huge corpus of data so that the pre-training process is very simple, and in the fine-tuning stage, you can fit it with a different data set and adapt it to a lot of different applications. The pros of BERT are that its bidirectionality allows it to read sentences from both the front and the back, which means it can better capture the context of each individual sentence. On top of this, it uses a self-attention mechanism to rank the importance of words in each individual sentence, so it knows which words are important for developing the context of a sentence. So it's better at understanding context for NLP tasks like semantic analysis. In terms of cons, BERT is both computationally and time-wise expensive, and on top of this, the fact that it's trained on such a large corpus of data means that if you fine-tune it to a relatively small data set, often it can overfit to this data set.
How did we measure the effectiveness of each model? First, we measured the accuracy of each model, which is just the ratio of correct predictions to total predictions, and this is a good metric of how well the model works overall. We also calculated the F1 score for each model, which combines precision and recall, and this is good for more unbalanced data sets. And finally, for each of the models, we plot an ROC curve, which is a receiver operating characteristic curve, and that shows how well the model works for a variety of different classification thresholds. And by measuring the area under that curve, we're able to measure how well the model works overall.
So we also generated the confusion matrices for all 3 different models, which gave us information on true positive, true negative, false positive, and false negative predictions. And we can see that consistently the true positive and true negative predictions are higher than the false ones for each of the models.
The second visualization we completed was the ROC. And you can notice that both of the gradient boosting frameworks had a sharp increase in the false positive rate in comparison to the true positive rate at a certain threshold point, which indicated that after the negative class got large enough that the model started to lag behind in correctly identifying true positives, whereas the BERT model, which I mentioned earlier, is a lot better at understanding the overall context of sentences, had a much smoother transition over the curve, which meant that it was better at generally classifying things as positive in comparison to negative in the right order.
So having created our confusion matrices and our ROC curve, we're able to measure all the various metrics that we discussed earlier, allowing us to better compare the performance of each model. So when it comes to the accuracy and the F1 score, XGBoost performs the best with LightGBM coming in second, and BERT falling short of those two. When it comes to the area under the ROC curve, though, BERT outperforms the other two, with XGBoost coming in second and LightGBM falling short of those two for the area under the curve. Our research does, in terms of the key findings of our research, gradient boosting is better when it comes to absolute metrics due to regularization and ensemble techniques in order to limit those effects.
And just to speak on that a little more directly, the absolute metrics we're referring to were the accuracy and F1 score we talked about earlier, and the regularization is the ability of the model to limit the importance of the training data in affecting how its validation ultimately results. And the ensemble model learning style that we're talking about refers to the fact that the model uses weaker versions of itself to eventually train like a larger version of itself so it can learn from its past mistakes. On the flip side, we noticed that the BERT model was a lot better at the relative classification based off of the ROC and AUC. And the reason for this that we believe is because of BERT's bidirectionality and also the self-attention mechanism, which means that it can better understand context. You will notice in the chart at the bottom of the page that BERT's training accuracy and validation performed a lot better than its training accuracy and loss performed a lot better than the validation accuracy and loss, which we believe indicates that BERT was overfit on this specific training set. So in the future, we would need to implement regularization to control for these things.
So our research does have some limitations and some future improvements we can make to it though. One limitation is inconclusiveness that's caused by various uncontrollable factors. This can be improved upon in the future by training more data sets and adding more hyperparameters. Some other enhancements we can make to this research though in the future is not restricting ourselves to a binary classification and expanding to a multi-class classification. So expanding from not just positive and negative to a broader range, such as a scale from 0 to 5 or various other segments. We can also use an ensemble model that combines the benefits of each of the types of models we use. So using the benefits of LightGBM and XGBoost and combine that with the benefits of BERT to enhance the overall performance of our research. Thank you.
Hey guys, first of all, great job on explaining all the three models and how they work. I think that's a great thing. One question about the data set. So, you guys mentioned a lot of great techniques like vectorization, vectorizers and linearization. What was the length of each of the data? So like how big was each of the input that you guys were putting in? And did you guys experiment with chunking and any of those techniques?
Yeah, so on the dataset slide, there's a chart, but generally, they range in general from a couple of sentences to several paragraphs, so relatively short. You can see there's a big spike. So, and that's the character count, so not too large.
Nice analysis. I would say it's more like comprehensive analysis research work. Because you are now proposing a new model, right? Let me see. And you are using the IMDb dataset is binary segment classification, right? Or did you conduct experiments on, for example, 5 more fine-grained sentiment analysis? Like 5, the scale of 5?
Yeah, so this one was just positive and negative, and it was evenly divided, so there's an equal amount of positive and negative reviews.
Another question is, have you analyzed like the trade-off between efficiency and accuracy?
Yeah, so I think that comes into play when we were comparing on accuracy and F1 score, when we saw that XGBoost performed a lot better than LightGBM, even though they have the same structure, and that's because LightGBM focuses on memory efficiency, whereas XGBoost is focused on a depth tree structure when it's evaluating its gradient boosting. And for BERT, which is completely different, we noticed that that one is a lot more computationally expensive. So for the relationship between something being computationally expensive and then also the memory efficiency and then also its accuracy, that research still needs to come, but we would say right now, we found that the absolute metrics of evaluation perform better with the gradient boosting frameworks, and the relative classification of things as positive and negative perform better when we use BERT.
Okay, thank you.
All right, our next presentation is Auditory Unveil. Give it up for them.
How are you feeling up today?
I can't believe today was the last day of college.
Congratulations on graduating. You must be so overjoyed.
I'm not really overjoyed, but thanks, I guess. Now, let's imagine that we upload a model where my personal assistant here could actually understand my tone.
Model uploaded.
How are you feeling after today?
I can't believe today was the last day of college.
I'm sorry. Major life changes like that can be difficult.
Thank you. Now, right there, my personal assistant was able to tell that I wasn't feeling that great. I was feeling pretty sad, and reacted accordingly. And in a world where we interact with machines more and more through varying ways, tone can be a very important aspect of that. This is our project, Auditory Unveil, Decoding Emotions in Speech. My name is Tejas Kumran.
I'm Lily Gledbeck.
I'm Harper Wood.
My name is George.
And I'm Oscar Lay.
And this is Auditory Unveil. So what is Auditory Unveil? Simply put, it's a convolutional neural network that uses image classification to decode emotions behind speech.
So here we have two
Kids are talking by the door. Kids are talking by the door.
So those two audio samples have the exact same speech. They both say there are kids by the door. Now, in the first voice recording, there's a fearful or scared tone, while in the second one, there's a happy tone. Now, this can lead to two very different contexts. Maybe in the first situation, there's someone that you don't recognize at the door, and you're scared, you don't want to open it. And in the second situation, maybe it's someone you recognize, maybe it's neighbor's kids from down the street, and you're excited to see them, and you'd want to open the door. In both situations, you're saying the exact same thing, but you can have two very different contexts and react in completely opposite ways from each other. And that's part of why tone detection can be really important, especially in something like the English language, where even when texting each other from a friend to a friend, we need things like emojis and tone detectors to actually tell, oh, this person is happy or sad. Now, both of those voice recordings came from our RavDesk dataset. We used a combination of 4 different datasets, RavDesk, Prima, Tess, and Savi. And in total, we had about 11,000 total voice recordings. And our model doesn't directly actually analyze the voice recordings themselves, but rather the Mel diagrams of those. So a Mel diagram, just for context, is a graph that represents a voice recording. So on the x-axis, you have the time, as time goes on in the voice recording. And on the y-axis, you have the hertz, or the frequency. Now, the different colors in the graph represent the amplitude at each of those frequencies. So once a voice recording is turned into a Mel diagram, different shapes can point to different types of tones, which our model can detect and be able to tell, oh, this person's happy or sad, etc.
Now, let's go on to the tools and technology we use to make this project come together. First of all, of course, since this is an AI project, it was essentially based entirely off of Python, with Jupyter Notebook to help just make code execution so much easier. And then to assist, we used Pandas and Librosa. Pandas we used to store the data values as data frames, as well as hold the paths of the audio files and the actual classification of the audio files together. And we use Librosa, which is an audio manipulation library, which we use to actually get in the audio files and convert them into the mouse spectrograms as said before. We also use matplotlib and keras. Matplotlib being the library we use to actually save the files, as well as edit them and get them ready for the AI model to use. And speaking of the AI model, we use keras, which is a sublibrary of TensorFlow, which, of course, I'm sure you all know, is the AI library which is primarily used to just create models and is what made this entire project possible.
Now, let's talk about the model that is Auditory Unveiled. Our model was trained using supervised learning, which means that for each input file in our data set, the emotion behind the speech was already known. Then, when the model was trained on the data, its weights were adjusted until the model was fitted, which means that it produced the correct outputs, that is, the correct emotions were identified. Additionally, our model is a convolutional neural network, and this architecture is especially suitable for image classification, which is why we used it to work with the spectrograms generated from the audio data. In each convolutional layer of our model, a feature detector, or filter, passes over each section of the image looking for a particular feature. The neural network can discover different features in the spectrograms which correspond to different emotions, which is how it accomplishes its purpose of emotion detection.
Now, let's talk about the results of our model, and I believe that they're actually incredibly impressive. When we began, without adding any modifications to the data, we only started out with around a 51.74% accuracy. However, through improving the model, through optimizing layers more, and data normalization, regularization of the actual model, we were actually able to increase the validation accuracy to 82.68%, which is a massive jump. And I would also like to point out the confusion matrix underneath the image-based CNN aspect. It is, I would like to mention, it's just a gorgeous confusion matrix. And we believe that this is actually a breakthrough in the accuracy of these types of studies, where we're decoding emotion through audio analysis. As a study done in 2022, using the exact same data set as ours, was only able to get a 61.59% accuracy level.
Some of the challenges we encountered throughout our project include the deprecation of the Librosa functions, where some of the Librosa commands didn't function as intended, forcing us to review our existing codebase and make accommodations for the updated library. Another pivotal change was switching from a 1D to a 2D CNN model, and this was done because of the abilities of the 2D array model's ability to capture both temporal and spectral features more efficiently, allowing the model to recognize more complex audio patterns. Originally, our design centered around audio classification. However, as we encountered challenges with accuracy, we shifted our basis onto more image classification.
So with the success of our model, there are many possible applications of emotion detection on the real-world applications. For example, voice-controlled technology. So by implementing emotion detection into devices such as Amazon Alexa and Siri, you can better get more accurate responses from user commands. Secondly, with healthcare and well-being, by implementing emotion detection into stress management and telemedicine, you can get an overall better communication between doctors and clients. And with law enforcement and security, by implementing emotion detection, you can get more improved emotion monitoring and exception detection.
Thank you for listening to our presentation.
Some of them that was training and then some of them that was
So our data set, we basically mixed all of them up since there were different variations between some of the data sets. Some of them would have the same voice actors repeating the same phrases, just so the model wouldn't overfit, while some of them had different actors, different scripts, and different phrases, all in different tones. So we basically took all 4 data sets, mixed them up, and then separated them into a training validation set at a 4:1 ratio. And that's how we made sure that we could get a proper accuracy rating.
Did you ever look into like how an individual data set performs on the test set? Like maybe one of the data sets was harder than the other ones? It's okay if
Yeah,
not.
sorry, we haven't, no.
Okay.
Do you try the large commercial models on this task?
We did try a series of models, but not that one. We tried image classification using ResNet 50 as well as dynamic time warping. Oh, and RNNs as well.
I'm not so familiar with the speech recognition, but I think on OpenAI they do provide some APIs for emotion detection. Or do they?
I'm not actually aware of OpenAI providing a service that provides emotion detection.
Well, I think it's not hard to implement. I mean, they can do a lot of pre-training. For example, they can do from speech to generating the analytical contents, and they can generate whether the sentiment is positive or not. I don't know yet because I don't work on speech. I work on natural language text. But I believe that they have a capability in training a model for doing this.
Hello guys, I love the robot start. So you guys talked about that you guys achieved a breakthrough, and so I wanted to just understand the thing. So in that one, so you said that you mixed 4 data sets. So that paper, does it also use all those 4 data sets? Because you said it performed better on one of the data sets, I think the RAB-DES one. So is it that the breakthrough is in you have much better data and augmentation, or is it that the model is the one giving the result?
I believe that it is a bit of a combination of both.
Okay.
Because from what I understand, the research study that I cited earlier was actually, they used the exact same data set as ours. It wasn't just an individual data set.
So all 4?
All data sets, RAB-DES, CREMA-D, SAVI, and TEST, those 4 were used in combination in our research project as well. And from what I understand, we were able to apply more ways. For example, something that we applied was normalization of the data, which I believe that they did not apply. And another aspect was we actually added additional images into the folder, which were like alt images to increase the training. And then they were essentially randomized and given a random, either a stretch, a pitch change, or it just added additional noise. And I believe that the combination of those 3 things just added so much more accuracy compared to this, because I would argue that a 20% accuracy is pretty massive.
So you guys looked at the previous paper, this one, and then found what they did / not do, and then you guys chose to implement that, correct?
Actually,
or was it the other way around?
We found this research study very, very late into the while we were creating this PowerPoint.
Really?
Yes. So we actually originally based it off of essentially a catalog data set that just had, because that's where we sourced all our data from. And we were not aware that this research study actually existed already, but we beat it. Good job.
All right, thank you, Auditory Unveil. Next up, we have scaffolds. Give it up for them.
Just to note also, we do ask for the safety and security of the flight that you use the lavatories and your
Listen at airplanes in the night sky like shooting stars. I can really use a wish right now, wish right now, wish right now.
Welcome to Onshore Airlines. My name's Elijah, and we'll be your pilots for today.
I'm Sophie.
I'm Luigi.
And my name is Matthew. Welcome aboard, everybody.
Now, this is no ordinary passenger flight. We are a military plane, and we'll be learning how to dogfight today. Luckily, we'll be doing this within the comfort of Unreal Engine. Our game implements realistic flight and shooting dynamics in order to create an authentic dogfighting experience. Trapped within the serene mountain landscapes, our planes will fight to the death, firing bullets at enemies and dodging return fire. Our game implements key Unreal Engine features like blueprints, raycasting, physics calculations, and skeletal meshes in order to create a real and useful fighting experience.
But first, what is reinforcement learning? Reinforcement learning is a branch of machine learning in which you have these AI objects called agents that are capable of learning behaviors in order to navigate through an environment. Think about your dog or your pet at home. When you want to teach it a trick, such as to sit, to shake, or to even potty in the right place, you would do so by giving it reward whenever it performs well. And on the other hand, when it makes a mistake, you would reprimand it gently or withhold that treat. Reinforcement learning follows a very similar pattern to this, where your agents will learn through trial and error. When I talk about rewards, I mean a positive signal that you give to your agents in order to encourage them to continue making that behavior in order to reach that end goal. When I say penalties, they are negative rewards. These negative rewards serve as a way for these agents to limit or prevent the agents to make the behaviors that they're doing. Reinforcement learning requires a lot of penalties and rewards in that system, and your agents, their main objective is to learn a strategy that will maximize its rewards within their given environment.
So we used Unreal Engine's Learning Agents plugin to help us with our reinforcement learning. And the algorithm we used was Proximal Policy Optimization, or PPO. And we decided to go with PPO because it's best supported by Unreal Engine and because it's one of the best policies for controlling continuous actions, such as adjusting velocity, for example. So one of the hardest problems we had to solve was figuring out precisely what observations we would pass into the AI, and after that, actually coding these observations into the game. So we needed a method for visualization, for essentially seeing that was easy to represent and at the same time not be computationally expensive. So we decided to use raycasts. And these raycasts, what they are is essentially sensors, and they went at the front of the plane, on top of the plane, and underneath the plane. And essentially what they did is they allowed the plane to ascertain the distance between itself and nearby obstacles that it might have to evade. So additionally for observations, we used egocentric coordinates, and we did that because the egocentric coordinates allowed the model to train in a more generalized manner. So additionally, we pass a list of actions into the AI as well, such as maneuvering left and right, rolling, throttling, braking, ascending, descending, and shooting. And from that, we built a reward system that would heavily reward a plane for downing an enemy plane and heavily penalize it for crashing or being shot. And on top of that, we had certain intermediate rewards, such as a small reward for shooting to allow the plane to want to shoot more, and a small reward for velocity so that the plane wouldn't move unnecessarily slow at all times.
So we tried replicating how humans learn complex concepts. We started by breaking it down into simple ideas. And then once we mastered those simple ideas, we can implement the complex concept. This is known as scaffolded learning in humans, and we try to do the same thing with AI. Instead of starting off with the agent and putting into dogfight simulation, what we did was started by just avoiding crashing into terrain. Once we got into avoiding crashing into terrain, we added shooting bullets and additionally and just moving around the terrain and tracking other airplanes. In this demo, you can see a completed agent fighting a statically programmed airplane in this demo.
Overall, we were pretty much able to hard code certain behaviors that we wanted in the model by using this model of scaffolded learning. It's really useful because it pretty much gains us an unprecedented level of control over the behaviors of the AI.
So our team faced a number of challenges throughout the game development process. One of this being really to understand and know all the intricacies of Unreal Engine. Some being, for example, the phishing scripting language, also known as blueprints, all very specific to Unreal. This learning challenge, in addition to a lack of information and resources on the specific machine learning agents package, as it was only released in this year of 2023, we found many difficulties as far as fixing bugs and really reworking our entire training process. In addition to this, we had a limitation of hardware. Our computers would crash during training, we would have difficulty loading the different landscapes, and overall, our overheated computers would have a hard time just simply editing our landscapes sometimes. And finally, another challenge that we had was our raycasts. Not only because we initially pursued only having raycasts in front of the plane, as Luigi said, we had to pivot kind of our methodology throughout and add vertical raycasts because it had to be able to operate within our enclosed training arena and not run into the wall or maybe go through the ceiling or any undesired behavior throughout the entire training process.
So to end off with some key points, reinforcement learning is a powerful concept that allowed us to train multiple agents to navigate the virtual world on their own. Unreal Engine's Learning Agents plugin allowed us to implement this reinforcement learning in a simpler way. And to end off with a quote from our team lead, Naveed, figuring out reward weighting is more of an art than a science. Thank you for your time and consideration, especially to our team lead, Naveed.
The experiment is done, so how did you build the environment for the experiments? Is it like a sandbox or simulations or what?
Yeah, so it was basically this enclosed landscape that I created using different components like the sculpted landscape, but then also using world barriers to create it just from flying out of the map completely. And any time that it would crash, although it wasn't shown in our demo, just so you could fully see the purpose of it actually flying successfully, when it wouldn't fly successfully, it would crash into the ground and the game would terminate, and as we shown too, it would receive a penalty.
And finally, how do you evaluate the process? For example, how do you determine like what type of optimization, like you use PPO, right? And you can also use like DPO or recently RL optimization tricks. So are you evaluating this process with success rate or what?
Success rate.
Yeah, so we essentially use PPO because the plugin for Unreal Engine is really built for PPO, and that's really what it supports. And as to how we determine the success rate, we get an output of a total accumulated points per episode of training. And so as the training time goes up, what we should expect to see is that this total number of accumulated points should also increase with time.
Actually, I was referring to like how do you evaluate your system? Are you evaluating like the final success rate or what? Or are you using the reward models for evaluation?
Yes, well, to be honest, our sort of really final evaluation criteria is sort of like eyeball method because we have so many different facets of the training since it is scaffolded learning. So instead of just focusing on what are the total output rewards for each level of training, for example, just flying training and then shooting training and evasion training, we just sort of focus on combining all these aspects together and at the end just sort of seeing how well it actually functions as we expected it to.
Okay, so it's like human evaluation.
Yeah.
So how do you determine like which action is better, and how do you determine like which framework, whether it is becoming better when you like change the parameters?
Yeah, so this was a difficult process as you're trying to predict human behavior, which can a lot of times be random and unevenly distributed, especially when it comes to gaming, as we all have different types or really personalities on how we play a game. So it's kind of difficult to find a one model fits all for going against a player, but we realized the more that the plane was able to shoot, and we incentivized shooting more, obviously, was a desired behavior.
Why?
Because with the more the planes shoot, there was no reload time or no lost ammo. So with an infinite shooting, you had higher chances of hitting the target plane.
Yeah, but you are using more resources. I mean, you are using more bullets. Okay, so it's nice work.
So that was Scaffold, and next up we have blockchain-based federated learning. Give it up for them.
Do you know that in 2025, the AI market is said to be worth $33 trillion? Now, there's many roadblocks that could limit it from reaching its full potential. And one of the ones which our research project aims to solve is through blockchain-based federated learning optimization. But now, before we dive into the research project, let's first take a look at the team. I'm Viswa.
I'm Brian.
I'm Drew.
I'm Jen. I'm Akshat.
And that's our research lead, Rowan, and our advising professor, Dr. Hitarshi Logan. Now, as said before, machine learning has a lot of roadblocks. And one of these predicaments is geographically distributed data. Now, there's data everywhere, abundant. But because of the unstandardized format in which it is, like we see in IoT, it makes it really difficult to be able to access it. And the next predicament is privacy barriers. Simply put, users don't like it when big companies like Google, Amazon, or Apple is accessing their data from their devices. Now, there is a solution to be able to take care of this, and that is federated learning. Now, federated learning is different from centralized learning, and in centralized learning, data is taken from a user's device and sent to a central server for model aggregation. Federated learning, on the other hand, sends a global model to a user's device, and in the confines of the user's device, trains it, updates the parameters, and sends model updates back to the main server, ensuring that data remains on the confines of a user's device. Now, there are some problems with this, including Byzantine attacks and adversarial attacks. And a way to be able to further optimize it is through
blockchain. So we wanted to leverage blockchain technology to improve some of the faults that we found. The first is we wanted to decentralize the federated learning process by bringing transparency into tamper-proof record keeping. If you guys don't know very much about blockchain, we essentially have a massive ledger recording transactions between nodes in the network. Additionally, we wanted to use a smart contract to automate the entire process, including rewarding people with money for using their data. Additionally, decentralizing the federated learning process brings a layer of security because no one party owns the entire process. We distribute the ownership and the power of the network to the people and to protect the data of the devices. So using blockchain, unfortunately, anything with blockchain always comes with some drawbacks. Anything you do on the blockchain usually costs time and money. So whenever you have data that you want to write to the network, you have to pay someone to essentially write it for you, a trusted party, and then it takes time to write that to the next block on the blockchain. And so we wanted to alleviate some of these problems by essentially reducing the number of transactions we're making to the network.
So moving on to the architecture of our project, it consists of three main aspects. We have a model requester, so this is a company or entity that initiates a request to the smart contract, basically sending the smart contract a model that they're requesting to be trained using users' data. So this smart contract is going to be stored on the blockchain. It stores the tasks which each represent a different model being trained on the network. It's responsible for initializing training epochs, which is the training cycles for each of these models as they're sent to users repeatedly as it gets updated. And at the end of each cycle, it fairly distributes incentivization funds to each user for contributing their data training to the network. And the clients are users who join the pool and are registered in the smart contract and train the data through a client-side application, with their data being aggregated in an aggregator tree, which Brian will talk about.
Yes, so essentially once the users are registered with the smart contract, they'll be given this aggregator tree where they will each be given a position in the tree along with their role. And so essentially every user in the tree will train their own version of the model and then send that up to their parents where they will aggregate their trained model along with the trained model of their children and keep passing it up until it gets to the root aggregator, which will then communicate with the smart contract, send a transaction where it will either redo the whole tree restructuring and do another iteration, or it will receive a message saying it's complete. And so for testing this, we use the Ganache Brownie CLI, which allows us to host our own blockchain on our local machines. And then for training, we simply used a linear regression model with the Titanic dataset using PyTorch. And then for communication between the users, we used Python sockets and Web3 Python library.
This graph represents our gas costs compared to another blockchain-based research study. We were able to minimize gas costs and dramatically reduce the cost to complete one entire task through limiting the transactions. Based on our architecture, we removed all intermediate transactions up the tree. By doing this, we were able to reduce the gas cost dramatically compared to that system. Similarly, the speed, due to reducing all blockchain transactions to a minimum, was reduced for not having to wait for a transaction to be completed and verified on the blockchain. Our model accuracy was very similar to the related study. Our goal was to keep it as close as possible without losing anything and ensuring we can reduce lower gas costs and increase the speed. In conclusion, we were able to alleviate many problems found in federated blockchain learning through iterating through our architecture. In the future, we would like to implement Merkle trees and test for security vulnerabilities. We would do this in the aggregator tree off-chain component. We like to test mirroring tree structures. We are currently using the binary tree. Using different ones might be able to min and max different speed levels. And we would also like to test on new blockchain technologies like Solana, Cardano, XRP, utilize a brand new smart contract features, stuff like that. Thank you. And I also wanted to mention, if you do look at our GitHub, we have a representation or like a visualization of the federated learning process pinned to our README, which is kind of cool. But thank you. If you have any questions, please go ahead.
You guys had mentioned that you improved the speed because you weren't making as many calls to the blockchain. And I don't know a ton about federated learning, so maybe this is silly, but is there extra time spent aggregating the models? Like, does that add to the total time?
So it does take some time. So since each user is using their data to update the model, each user will have their own aggregating time. But the key in saving speed for this process is the whole aggregator tree is off-chain, allowing us to save the most time in making transactions off the chain instead of on the chain where they have to be verified and executed. But yes, each user has to train the data using their own, train the model using their own data, so that does take an amount of time, but it'll be similar no matter what framework.
And then on that tree structure, what is how many nodes, or do you guys have in that final bottom layer where the actual model training is happening? Did you guys test out different numbers for how many models are in the bottom layer?
Our testing was very limited by our own machines because we were essentially training it or testing it using a bunch of processes on a single laptop. So that was definitely a bottleneck, but we did get up to like 14 different, and so testing it on different ones, essentially 14, it did work better accuracy-wise, but because it was running more, but it was very slower because it was using more time.
And also on all like in this case the 14 models, the different parameters. How did you guys choose the parameters that went into each model, or was that an automatic decision done by the tree, or was that something done manually by you guys?
So that would basically be when the model requester initializes the task in the smart contract. They would specify what parameters they'd be looking for.
Range of parameters?
Yep, a range of parameters. And so it would be for that task, that set of parameters would then be like a set of instructions for each user to be being trained on using those.
All right, thank you so much. Next up, we have Philip's team, Enhancing Cancer Detection.
Did you know that according to a UK study, approximately 50% of people will be diagnosed with cancer at some point in their lifetime? I know, it's a little scary, but the best way to prevent deaths is by detecting this cancer as early as possible. That's where our project, leveraging large language models for cancer detection, comes into play. Our supervisor was Dr. Sisman, our team lead was Philip, I'm Josh.
I'm Rashad.
I'm Jogan.
I'm Ela. And I'm Sachi.
In the past, image and visual analysis has been used to detect cancer. However, our model can detect cancer based on semantics. Using text improves accessibility for diagnostic tools and improves cancer screening as a whole. It can also improve cancer research in the future by easily categorizing collected information and conjecturing inferences based on categorization.
The dataset that we trained our model on was called Hallmarks of Cancer, pulled from a 2015 paper called Automatic Semantic Classification of Cancer Research According to the Hallmarks of Cancer. Each data entry was a one-sentence extract from an abstract of those research papers, annotated with one of 10 hallmarks, or several hallmarks, if it expressed them. We did have an imbalanced data set with about 80% of the entries labeled with the same hallmark. So to combat this imbalance, we sampled 1,000 entries from that majority class to help generalize our training. And we used the Roberta model to train.
The Roberta architecture features a self-attention mechanism, which allows the model to weigh the importance of each word in the input. The Roberta model was trained through supervised learning on a large dataset. The input embedding of the Roberta model converts each word in the input into vectors of fixed sizes. The positional encoding part of the model stores information about where in the input each word is located. The mass multi-headed attention mechanism deploys multiple attention heads across the input to store data about the relationships between the words by masking particular words in the input. And the FNN layer allows the model to store complex patterns within the data. And the normalization layer regulates the activation of the neurons in the neural network in order to regulate the learning rate.
For repeated testing of our model's performance, we obtained the best result from using 5 epochs, a batch size of 8, a learning rate of 1 × 10⁻⁵ power, and a max embedding length of 256. Using the Roberta model, we found that the maximum number of tokens was 192, so we used a larger token size in order to compensate for variability in the dataset.
So to evaluate the effectiveness of our model, we used a variety of metrics to determine how well it made predictions. So the accuracy, of course, tells us the number of correct predictions the model makes, and we had a very high accuracy of 0.907, as you can see. The precision tells us how many correct predictions the model makes out of all predictions for a certain class, and our precision was 0.849. And the recall tells us how many correct predictions the model makes out of all instances in a certain class, and our recall was 0.820. And as you can see, all of these metrics are very close to 1, so our model was generally very good at making predictions. If you want to consider a more balanced metric between precision and recall, you can take the F1 score. And we decided to calculate a weighted F1 score since, as we mentioned before, we did have an imbalanced data set. And so what the weighted F1 score does is it assigns a weight to every single class depending on how it is expressed in the data set. So this metric allows us to take into consideration the model's performance on underrepresented classes as well. And our model's performance, or our weighted F1 score was 0.826. Now, we can also consider the macro average F1 score, which kind of does the opposite, where it takes the F1 score of every single class and averages them, so every single class is evaluated equally instead of being weighted. And this helps us even out a very imbalanced data set. Similarly, you can take the micro average F1 score, where every single instance is considered equally, and it also helps us even out an imbalanced data set. But regardless of whether you decide to take into account the weights for certain classes or not, all of our F1 scores come out very close to 1. So once again, our model is making very accurate predictions.
Displayed here, we have a loss function for our training and validation phase. So we used a cross-entropy loss function, which generally follows the negative log x relationship. And as you can see here, it does follow that relationship very closely. The gap between our validation and our loss functions is very small, meaning that our model was not overfitting our training data and was learning meaningful relationships in the data rather than just overfitting the training data. So it was able to generalize well to our validation set. So that indicates overall successful training. And here we have the confusion matrix for our testing phase. So since we did use multi-label classification, this confusion matrix is an average of all of those classification tasks. And as you can see, we have a very high accuracy with true negative and true positive rates that are above 90. So our model is categorizing its entries quite accurately.
So in conclusion, based on our results, our model is able to successfully predict cancer hallmarks. With this in mind, it can be used as an effective and innovative diagnostic tool in aiding physicians in diagnosing cancer in the hospital and clinical setting. It could also be useful in parts of the world with a lack of adequate medical testing equipment or doctor deficiency. As a future direction, we could utilize multi-modeling by integrating semantics, as used in our project, and medical images into one model.
So for our demo, we tested our model using 2 separate inputs. So the first input we ran tests and shows that our model can successfully detect hallmarks of cancer. And as you can see under the input, you get the hallmarks of cancer. The second input that we just ran shows that our model can detect multiple hallmarks of cancer as well, which is especially important for detecting cancer in its early stages.
The confusion matrix you showed had all of the classes combined. Did you find like variability in the performance of different classes, or did you just look at them like combined performance of if it detected the hallmark or not?
We did just look at the combined confusion matrix since there were entries that had multiple hallmarks associated with them. So some of them might have 3 hallmarks, some of them might have 2, some of them might even have none. So we did just consider them all together.
And for the model, why did you choose Roberta? And then did you explore other models in that space of like transformers models?
So we did only use Roberta with this data set, but we considered using other transformer models because Roberta is like for generative text and we were doing classification, but this is what we ended up using and it ended up having factors.
Have you done analysis like what are the 10% of errors? It reaches like 80%, so what are the errors for that 10% or 15%?
So there's like instances where some of the hallmarks are mislabeled, or if there's multiple labels, the model doesn't catch all of the labels, it might do like 1 or 2 instead of all 3.
And then on the ones that was long, did you evaluate how long they were? So maybe there were some, let's say, misclassifications that maybe weren't the exact ones, but maybe they were similar. Did you guys evaluate maybe how similar their wrong labels were to the actual correct one?
So when we were calculating our metrics for the accuracy, we only considered correct predictions if every single label was matched.
All right, thank you guys.
Give us a second while we set up the next slides, but oh, man, finally done. How do y'all feel? Yeah, exhausted. I feel the same. So, what we're setting up right now is a QR code for y'all to vote the favorite team, People's Choice Award.
So this form is password protected, and the password is pineapple, like the fruit. So you would need to type in that password and then vote. With the form itself, you can vote multiple times, but we are only tracking 1 vote from your IP address. So please do not vote multiple times. We will know, and we will void the other votes. So we'll give you all a second to scan the votes, and you guys can vote for your favorite. Pineapple. Fruit.
Pineapple with lowercase and no spaces.
Let me know if any of y'all can access it. Hey guys, I think the form is not working. You guys should turn off your Wi-Fi's and maybe try. That might be the issue.
I think since we sent too many people at once, if y'all just give me some time, we should load it just fine.
some of y'all, like, you can continue voting, but please sit down because we do have a couple more things to say. And then afterwards, we will announce the final winners for both prizes, and then y'all can go home. But we'll wrap this up really quick, so please sit down.
Before you all go home, I'd like the participants to take one big group photo after we settle down, alright? So don't leave this yet.
Yeah, Michael's controlling.
Because like next slide is continuous.
Yeah, totally get up.
Before we start wrapping up this presentation, I do want to give a few shout outs. Our friend here, Fatih, is going to talk a little bit about that.
Good evening, everybody. I'm the finance director for ACM, and tonight's food was sponsored by Shalimar. This is a small business run by my uncle. How did you guys enjoy the food? For his restaurant, it's a website. I don't know if it's functional, but it is a website. If you guys like the food, maybe you can take your family out, even you guys can go visit.
All right, thank you.
So unfortunately, after this semester, we do have a good amount of people leaving, so we just wanted to give a quick shout out to the leads and the other people that are leaving. So we have Anish, Naveen, Rishith, Rohan, Vaishnavi, and Rowan. Can y'all stand up so we can give a quick round of applause? These 6 leads are truly, truly extraordinary, and like the projects that y'all done are just so mind-blowing. Like I've seen all of y'all go from participants now to leads, and you know, ACM Research is definitely gonna miss y'all, and you know, we wish you the best of luck for what y'all are doing in the future. So, yeah, and in addition to that, we are also leaving. So yeah. But yeah, just some quick words. This is my second semester as a director. I was director last semester, and then I was a lead the semester before. And you know, being ACM research director has truly been a privilege. Just you know, the complete change in the program and seeing the program grow, and now seeing all these amazing teams, you know, do such great research projects. It's truly been a pleasure of mine, and you know, I'm gonna miss this a lot. But I know that the next directors will do a great job at continuing the legacy of research.
Yeah, and as for me, like I had a blast being able to connect with y'all one-on-one, walking around the building and seeing what y'all are up to. I'm gonna miss it a lot. But I don't plan on leaving ACM just yet. So you'll still see me around.
So with the old officers leaving, we do have some new ones. So give it up for the new leads. We have Zara, Arya, and Vishwa. Daniel, Shira. Y'all can come on up real quick. The new leads, come on up real quick for pictures. Y'all want to be part of the center?
Okay.
Yeah. Do we need to like? Okay.
Like a lot of this. They do like a little view. So are you going to
I don't know.
bring everyone?
Oh, so permanent.
Yeah.
Cool. Okay. Yes. And with the new leads, we also have 2 new directors, so give it up for Philip and Sophie!
So I've been with research for 2 semesters already, one as a participant and one as a lead. It's been an amazing experience. We've just seen this organization grow thanks to CC and Arian and all the past co-directors and directors that were there. Yeah, this is gonna be amazing.
Yeah, I mean, it's been a bit of a journey for me. It's my 2nd semester here as an ACM research lead, and I'm very grateful for the growth that ACM research allowed me over the year. And I think me and Sami we're making some changes for sure. And I mean, like in a good way, obviously, but yeah, we'll see what happens. I'm very hopeful for the future, and hopefully we all do well. So that's all I got to say.
So with that in mind, now the only thing left to do is to announce the winners. So if you can give us 2 minutes, we're going to quickly finalize the winners for that and then get back to y'all. So, keep talking, but please stay for the winners.
Oh man.
I need to open the... We need to prepare medals. Oh, Brian. Oh, thank
You guys are ready.
Hey y'all, settle down please.
Okay. For the People's Choice Award, can I get a drum roll, please?
Explore the Central West. Two years in a row. Fun fact, this is Richard's second time winning People's Choice Award, so you got extra applause for him for that.
All right. And for the best research award this semester,
It's this one. Y'all can come on.
Oh, here?
Oh, really? Wait, hold on.
Wait, let's go to the
Yeah. Okay, I'll put it there. Congrats. You're a director too. This is amazing. Yeah, the robot, go over there. Can I have my mic, please?
And we do have one more.
So, this semester, our judges decided that they wanted to give hey guys, settle down. Next. So this semester, the judges decided they wanted to give an honorable mention to one team because it was really close to winning Best Research Award. So can we get a drum roll for the honorable mention? That is Blockchain Based Method Learning. Unfortunately, we don't have medals for you guys, but if you guys want to come up for a picture, that's cool too. All right, and that concludes ACM Research Symposium Fall 2023. Thank you guys so much for coming in. Thank you for the hard work y'all have put in this semester. Thank you to our faculty advisors, our judges for coming in. We really appreciate everyone's support to make this event what it is. And yeah, that's pretty much it. Thank you guys.
If you are participants, please stay. We'd like to take a group picture.
If you are a participant, please stay and come on up. We're going to take a group picture, and then we're going to do leads after.
Thank you, guys.
Thank you.
Thank you.
Thank you, Michael.
Let's go.
Oh, he's taking pictures. Do you want that in the live stream?
Huh? Oh, shit. Can you do that? I'm gonna go.
Can you like it?
Oh, is it?